So we'll start the next one, that is the design of pumps. So in the previous video we have seen what are the various types of pump and what is the requirement of pump. So what is the main requirement of pump? It is to increase the pressure. Okay. So sometimes we call this pressure as pressure head, or we can say in most of the time instead of using pressure we use the term pressure head. So if P stands for pressure, then the pressure head stands for P divided by gamma W. Okay. And what is the meaning of gamma W? This gamma W means unit weight of water. This value is a constant for water, that is unit weight of water. So this value, this generally comes in meter. The pressure head value comes in meter. Now if we take the same example, then the height of building up to this point is 15 meter. This is 10 meter and this is 5 meter. So up to here it is 15 meter. I want the water to be lifted up to this level. So this is the level up to which the water should be lifted. So let's assume that this is 5 meter, 5 meter and 5 meter. So again 15 meter the water has to be lifted. Okay. So same example we are continuing. What is this water level? This is the level of water which is present in the overhead water tank. I hope you have seen one experiment. In this experiment, if these two bowls are connected with a pipe and if I add water to the first pipe, then what is happening? Slowly the water level will decrease because the water will start increasing, the water will start flowing through this and it will also enter in this second container. So up to what point the water will keep moving? Up to when the water level in both the containers are same. Up to when the water levels in both the containers are same. Okay. So at that point only the pressure head will be same. That is the level of water from the ground will be same. So same concept we are applying here. If this is the level of ground and if the water is present up to 15 meter, that means the water will rise up to 15 meter in this building. But we need to transfer water up to the 6th floor. That is we need more 15 meter the water to rise. So which instrument to use for that? We will have to use the pump. So here I am drawing, this is a pump. Okay. Now this is the level of water which was 15 meter. Okay. So this is that level. Now from this level I have to shift the water to a level that is 15 meter above 15 meter above this level. This is the level in overhead water tank. Once again we'll see the diagram for more clarity. See, this is the level. Now we want to shift or we want to transport the water from here to the last floor, that is the 6th floor. So the distance is 15 meter. This is the 6th floor. So we'll use a pump for this. Now one pipe will be inserted, to this level. Okay. And the present another pipe will be present at the level where the water needs to be transported. Okay. Now if we draw the center line of the pump, then this head is called as suction head. Okay. This HS stands for suction head. That is water is sucked now from this point into the pump. So this is suction head. The distance from the center line of the pump to the level up to which the water has to be lifted, this head is called as delivery head. So this HD is called as delivery head. And if you have studied the fluid mechanics, then you know if the water is if the water is flowing through the pipe, there will be some head loss, there will be loss, and the major loss is due to friction. There are two types of losses, major loss and minor loss. The major loss is among 80 to 90%, and this major loss is due to friction. So whatever the head loss will be there due to friction, that will take it as HF, that is frictional loss. We will write it friction head loss. So total head will be suction head plus delivery head plus frictional loss head. So this is our total head. So from this diagram we can say that HS plus HD, HS plus HD, what is the value? So HS plus HD value is 15 meter. But we will have to consider some losses also. So we have to find out what are the losses, and then we have to add to this value. Then we'll get the total head, that is H value. Okay. Now the next point is work done by the pump work done by the pump in lifting Qmax. This Qmax means meter cube per second. Okay. Qmax of water Qmax of water by a head H. That means if we want to lift the water by the head H, that is up to the height H, then what is the work done? So for this, the work done is equal to gamma W into Q into H. Okay. So this is the formula for work done to lift the water up to height H, where gamma W is called as unit weight of water, Q is discharge in meter cube per second, and H is the total head. And how to find out this total head? Suction head plus delivery head plus head loss due to friction. So with all these formulas we can find out what is the work done in lifting the water up to height H. Now if you want to find out what is the horsepower of the pump required, so there are two types of horsepower. The first is water horsepower. Water horsepower of pump. This is called as WHP. So this WHP is given as gamma W into Q into H divided by 0.735. Now what is that 0.735? So we know 1 horsepower is equal to 735 watts. 1 horsepower is equal to 735 watts, and this is equal to 0.735 kilowatts. So from here we have taken the 0.735. Now the unit for this W, will write it here. The unit for W is kilonewton meter per second. Now one more formula we have to see here. If efficiency is given, if efficiency of pump is given, then we can calculate the brake horsepower. the brake horse power, that is called as bhp, and the formula to calculate the brake horsepower bhp is equal to water horsepower divided by efficiency of pump. Water horsepower divided by efficiency of pump. So these are the three formulas which are very important while designing the pumps. Other than this, there are few formula which you have studied already in the fluid mechanics or hydraulics. Okay, so the first one is Darcy-Weisbach formula. Darcy-Weisbach formula. So according to this, HF, that is head loss due to friction, is equal to FLV square by 2GT. FLV square by 2GT. In terms of Q, we can write it FL Q square by 12.1 into D to the power 5. So you can just revise the notes which are already there in the channel and see what are these individual units, small f, L, Q and everything. Right now we won't be wasting any time in this. The second equation that you should know is Hazen-Willian equation. Hazen-Willian equation. So this equation is V is equal to, that is velocity is equal to 0.85 C. This is Hazen constant. So that is Ch, R to the power 0.63, H to the power 0.54. Okay. So velocity we can find it out by using this equation. So these are the main formulas which are provided or which are used for design of pumps. In the next video, we will take an example and design a pump for a required problem. Okay.